Mount Pinatubo and the Ring of Fire. On July 16, 1990, a large earthquake struck Luzon, an island in the Philippines. The earthquake devastated cities for hundreds of miles around and killed more than 1,600 people. Yet the destruction was not over. 2 weeks later, residents of Luzon discovered steam coming out of a volcano called Mount Pinatubo. But when scientists inspected the volcano, they did not find any evidence the volcano would erupt. However, on March 15, 1991, villagers on the northwestern side of the island were startled by a series of earthquakes. The earthquakes continued until 2 weeks later, when Mount Pinatubo began to rumble. On April 2nd, the mountain sent an explosion of steam, water, ash, and rock into the air. Over the next several weeks, it continued to belch volcanic ash into the air. Scientists detected increased levels of carbon dioxide, a sign that hot liquid magma was nearing the surface. By June 7th, a dome of lava 130 feet high and 660 feet across had formed on the surface of the volcano. 5 days later, the volcano erupted. Hot volcanic ash rose about 20 miles into the air. An ash cloud of almost 50,000 square miles blanketed the island in darkness. The summit of the volcano was blown off, replaced by a new hole 1.6 miles wide. 847 people in surrounding communities died, most of them when their roofs, buckling under the weight of wet ash, collapsed. Geologists would later rank the eruption of Mount Pinatubo as the second largest volcanic eruption in the 20th century. While scientists have never determined whether the earthquake in 1990 directly caused the volcanic eruption a year later, the two events are generally considered to be related. Although it's difficult to predict when or where an earthquake or a volcanic eruption will strike, these events can occur in patterns. Mount Pinatubo is located on the Ring of Fire. The Ring of Fire is a horseshoe-shaped zone characterized by earthquakes and more than 450 volcanoes. It is 25,000 miles long and runs roughly along the edges of the Pacific Ocean. The Ring of Fire begins on the southern edge of South America, runs north along the western coast of the Americas, cuts across the southern edge of Alaska and down the eastern edge of Eurasia, before culminating in a series of deep trenches, several thousand miles off the coast of Australia. 75% of the world's active volcanoes are located on this ring, and almost 90% of the world's earthquakes have happened there. The reason why so many earthquakes and volcanic eruptions occur here has to do with the plate tectonics. On the surface of the Earth is a patchwork of enormous plates, atop which all geographic features, seas, oceans, fields, mountain ranges sit. These plates are in constant motion, although they move very slowly, under 6 inches per year. These plates separate, collide, or slip past each other along their boundaries. These movements are referred to as plate tectonics. Massive events such as earthquakes and volcano eruptions can occur along plate boundaries. Most earthquakes occur in areas often close to plate boundaries. Areas that are in the middle of the plates generally do not suffer from these forces. This is why there are earthquakes in San Francisco, which is close to where two plates slide past each other, and usually not in Chicago, 1,000 miles away from any plate boundary. Similarly, volcanoes tend to form near plate boundaries where the movement of the Earth's plates create vents, which are openings on the Earth's surface. Magma, liquid rock located below the Earth's surface, can rise toward the surface of the Earth and erupt out of volcanoes. The island of Luzon, where Mount Pinatubo erupted, is near a location where a sea plate has been sliding under a continental plate. The location of mountain ranges is also closely linked to the activity of plates. The collision of two continental plates has formed Earth's tallest mountain ranges on land, such as the Himalayas. These mountain chains are essentially crumpled up parts of continental plates, formed when two continental plates push against each other. Deep ocean trenches, such as the Mariana Trench of the Pacific Ocean, can also form along plate boundaries. The Mariana Trench reaches almost 7 miles down. If you look on a detailed map, one that includes physical features, such as mountain ranges and trenches, you will begin to see patterns. You may even be able to guess where some of the giant continental plates are located.